Hi, everybody. Hope you are doing well. We are continuing on the same series, naming and drawing hydrocarbons. We started naming the alkanes in the previous video. We did a lot of practice on naming alkanes, and we set certain rules to name alkanes. But from now, the complexity will increase because alkanes are not just alkanes. We have different types of alkanes. There is an N-alkane or normal alkane, and these alkanes are normally chain, unbranched chain. And these types of alkanes we saw already in the previous video, and we did a lot of practice on them. The other type of alkane is the branched alkanes. It means there is a branch emerged from the alkane chain or from the alkane backbone. It's not normal, but it has a branch. This branch, the branch can be a substituent. And for this specific case, we have some minor changes for the naming rules that will help us get the right name. But first, what is a substituent? A substituent can be an atom or group that replaces a hydrogen in an organic compound. The main chain hydrocarbon has one hydrogen or more that is replaced with an atom or group. And that's why it is called substituent, because everyone substitutes one hydrogen in the main hydrocarbon. Sometimes this branch can be another hydrocarbon group. If this is the case, when an alkane branch, this branch is called, in this case, alkyl group. We just replace the suffix "ane" with "yl". In that case, when the alkane group is the branch, the alkyl group is a substituent. For this branched group, we will use the normal naming rules for alkanes, but just to replace the suffix "ane" with the "yl". For example, if the branched group is a methane group, so it will be methyl. If the substituent is a halide, we have different types of substituents. It can be alkyl group or halide. These halides are halogens, comes from halogens. Chlorine, bromine, fluorine, iodine, all of these are called halides, and we will study them more later. In this case, we will replace the suffix "ide" in the halide with "o", and we'll learn more about it later. As an example, if this alkane becomes a branch in another hydrocarbon chain, it means that one of the hydrogen will be replaced with another hydrocarbon chain. It means that it will lose one hydrogen in order to connect to the other hydrocarbon chain. For example, this alkane has only one carbon, so it's methane. When it loses this H and becomes a branch, it will be a substituent. And in this case, we will remove this "ane" with the L, so it will be methyl group. And the general name is alkyl group. For example, in this chain, the main chain is this one, 1, 2, 3, 4. This is a butane with a branch. The branch comes from methane because it's only one carbon. For the branch, we use the normal naming rule for alkane. So this was methane, and it is a branch. We will convert the last suffix. So this is methyl group. And it substitutes one hydrogen of the main chain with this group. Some of the substituents you must know, or the alkyl group that you must know: CH3 with one carbon is methyl. CH2, CH3, which is two carbons, it's ethyl. CH2, CH2, CH3, three carbons, propyl. So they come from the normal naming, methane, ethane, propane, but just replace the suffix "ane" in the alkane with "el", methyl, ethyl, propyl, butyl, and so on. And when you find a group or a hydrocarbon that ends with "yl", this means that it is a side chain, not the main chain. How do we know? We will know right now. Naming rules for substituents. If the substituent is an alkyl group, we add the "yl" to the alkane prefix. The alkane prefix, if you remember, meth, s, prop, but, and so on. We have a table for them from the previous video. So for the meth, it will be methyl, the S will be ethyl, prop will be propyl, but will be butyl, pent will be pentyl, and so on. What if you have more than one substituent? So the main hydrocarbon chain has many branches, and each branch is another hydrocarbon group, another alkyl group. In this case, we arrange them in alphabetical order. We will alphabetize the substituent, not according to the number of carbon atoms, but according to how does it order alphabetically. For example, if there is a branch of acyl and another branch of methyl in the same hydrocarbon, we will name the acyl first. We will add the acyl before the methyl because simply the E comes before the M. If we have different branches of the same substituents, so we have 2 or 3 methyl or acyl groups, they are the same. In this case, we will use the prefixes of di, tri, tetra, and so on. And you know this from previous years. Mono for 1, di for 2, tri for 3, tetra for 4, and so on. Also, if we have more than one alkyl group or one substituent that are identical, we separate their numbers with commas, like 2, 3, and then dash. After dash, you will write the mean. I know things are not clear yet, but they will be very clear when we have examples. Connect numbers and words with hyphens. Example, 2, 3, dash, dimethyl if you have 2 methyl groups. Let's have this example. We will apply the rules of this example. To name a branched alkane, I would need you to write notes of this. To name a hydrocarbon with branches, number 1, detect the main hydrocarbon chain, the backbone. How can I detect the main hydrocarbon chain or the main backbone? It is the longest chain. Take care, it is the longest, not the straightest chain. So if it is wrapped but still continuous, this is the longest chain. Second, when you detect the main chain, the main backbone, start numbering from the carbon that is closest to the branch. The carbon that is closest to the branch will have the lowest number, will be carbon number 1. Then start naming the substituent, the branches. If the substituent is an alkyl group, use the normal alkane naming rule, but just replace the suffix "ane" with "l", YL. If you have different branches, you will number them and you will need to alphabetize them if they are different. If the branches are identical, count how many branches of the same group and use the prefix di, tri, tetra, depending on the number of identical branches. Let's do this here. We need to identify the backbone, the main hydrocarbon chain. So we have branch here and we have branch here. If we start numbering from here, 1, 2, 4, but we still have continuous carbon, either this or that, 5. This is one way to number. Or we have another option to number it from the other side, 1, 2, and 5. To go this direction or this direction, we get the same number of continuous carbon atoms. This is the backbone. So we have to decide from which direction we have to start numbering. If you consider this is the branch, and you will start numbering from here, then 1, 2, and 4. So in your opinion, try to interact with me, okay? In your opinion, which is the correct numbering for the main backbone and why? Take a moment to think. First, let's exclude. Which one we can exclude? Which color? The blue one, because it gives a shorter chain, but we have to find the longest chain. This gave us 4 continuous carbons, but other numbering gave us 5 continuous carbons. So we have neglect this way of numbering because it doesn't give us the longest chain. Both the 2 other numbering give 5, penta. So the main chain is penta, but which direction? According to the rule, we should have the carbon atom with the lowest numbering the closest to the branch, to the first branch. If we use the green numbering, the first branch is at carbon 2. But the red numbering, the first branch is at carbon 3, right? So we have to exclude this numbering and we consider this numbering with the green numbering. Now we know the main backbone. The main backbone is 5 carbons. 5 carbons means bent, so you have to write it first. And there is no any double bonds or triple bonds, so this is ene. This is saturated alkane, pentane. This is the main carbon backbone. Okay, this is the second part of the naming. In the first part, we should add the substituents. So let's see what are the substituents. We have a substituent here and a substituent here. We have here one C, one carbon, and here one carbon. So this is methyl group. They are two methyl group. Where are the positions? So two methyl, two identical branches, so they are dimethyl group. We need to number them. One on carbon 2 and one on carbon 3. So it is 2, 3. We separate the number with comma, then dash to add the group. We separate the numbers from the letters by a hyphen. Separate the numbers from each other by commas. Separate the numbers from letters by hyphen. So it's a 2,3-dimethyl pentane. Pentane, the main chain name comes at the end of the naming. And the first part is the branch. So this compound is 2,3-dimethyl pentane. What if the branches are not identical? For example, if we have a branch like this, consider we count the backbone as pentane because it is, but here, how many carbons do we have in this branch? In this branch, we have one carbon here and the second carbon here. So to name this branch, 1, 2, 2 carbons. So this comes from ethane. So this is the ethyl group. This is ethyl group. So we have a branch of ethyl group and another branch of methyl group. How can we name it now? In this case, we will follow the same numbering order because the closest branch is here. So this will be carbon number 1. The closest branch is on carbon 2. In this case, it is pentane as well. So we'll write pentane. This is the last part of the name, and the first half of the name is the branches. We have a methyl group on carbon number 2 and an ethyl group in carbon number 3. In this case, how can we put them? Do we name it 2-methyl 3-ethyl pentane? What do you think? Is that correct? Awesome. This is not correct. Why? Because when we have different groups, we have to alphabetize. Ethyl comes before methyl in the alphabetical order, although it doesn't come before methyl in the carbon order. In this case, we will name it 3-ethyl 2-methyl pentane. Okay, we'll talk more about this in the next examples. So this compound is 2,3-dimethyl pentane. Let's have some examples. The first one is very easy. It's not branched. It's normal alkane. We need only to count the number of carbons. 1, 2, 3, 4, 5, 6. 6 if you remember hex. We don't have any unsaturated bond. This is ene, alkane. So this is hexane. What about this? So let's count the number of atoms of carbons. From where I would start the numbering? Of course, from here, because this is the carbon that is closest to the first branch. 1, 2, 3, 4, 5, 6. So the main backbone is hexane. Write it first, and then you have to name the first part of the name. So the branch, I have to name the branch. The branch has only one carbon atom. So this is a methyl on carbon number 2. So this 2-methyl hexane. Let's have another thing that is more complicated. Let's practice this. So we have many branches here, I think. From which side I should number? Here we have 2 branches, so we'll number starting from this carbon. 1, 2, 3, 4. Do we have another way to number? We can number starting from this, but this is the same because our branch will be on carbon number 2. 1, 2, 3, 4. We still have 4 carbons, so this is the backbone. The backbone is butane. Why butane? Because it has 4 carbons and no any unsaturated bond. This is the second half of the compound. The first half, the branches. The branches seem identical. They are all methyl groups because 1 carbon in each of them. Here we have 2 methyl and here we have 1 methyl. 2 methyls on carbon number 2. In this case, we will write 2, 2, and the third one is number on carbon 3, 3, then dash tri methyl butane. So this is 2, 2, 3 trimethyl butane. Okay. This one, this is a little more complicated. Let's see how we number the backbone, the main hydrocarbon chain. If we start from here, this is 1, 2, 3, 4, 5. So the branch is on carbon 3. Let's see how we'll get if we start from the left. 1, 2, 3, 4, 5. Same hydrocarbon chain length, same position of the branch, carbon 3. We can start numbering from here and consider this as a branch. It's okay. 1, 2, 3, 4, 5. So we still have 5 carbons as the main hydrocarbon chain length, and the branch is on carbon 3. So either ways is correct. Consider that the main carbon chain you should move with your pencil without interruption continuously. So the main carbon is pentane. So you have to write it's 5 carbons, so pentane. So write pentane and let's see what is the branch to write it before the name of the main hydrocarbon chain. This is the branch. How many carbons? 1, 2. So this is ethane. We will replace ane with the suffix of alkyl group, -l. So this is ethyl group. On carbon number 3, 3-ethyl pentane. 3-ethyl pentane. It's your turn. I will need you to try to name the other compounds. Practice. Guys, the secret is practice. Practice, practice, practice. Don't skip practicing. Okay? Especially next times, the things will be more complicated. I will consider this number 1, 2, 3, 4. This is number 4 and 5. So this is your homework. Write in the comments. Hydrocarbon 1 name is hydrocarbon 2, and so on. Thank you guys. That's all for today. I look forward to see your answers in the comments down below. If you have any question, just write it down in the comments. If you are struggling in different branches in chemistry, in the channel, I have playlist for several branches, general chemistry, polymers, and many others. You can have a look on them. Thank you guys. See you in the next video.